Welcome to this afternoon's colloquium. I'm thrilled to introduce Craig Zilles, who is a longtime professor at the University of Illinois in Urbana-Champaign. He and I actually know each other from work that neither of us does anymore, 15 years ago or so, where he was coming at it from the computer architecture side, and I was coming at it from the programming languages side. And if any of you want to hear about the beauty of transactional memory, you're at the wrong talk.
Yeah.
But Craig and I could sing the benefits of it for you. Now, his research is focused on bringing computing and data analytics to education, in particular the project he's going to talk about today, which is a computer-based testing facility. The floor is yours.
Yeah, great, thank you. So as Dan said, I'm Craig. I will be talking about this stuff. My experience giving this talk at other places is that there are questions, and it's more fun for me if you ask those questions, and then you also get your questions answered, so do stop me at any time. I do have a lot of stuff, so I'm just going to try to power through it more or less, so do stop me when you have questions, and otherwise I will just tell you about some stuff. So I'm actually going to try to communicate three things, the third of which is the computer-based testing facility, but to me, this is an enabling technology for doing some other stuff. That my claim is that we can increase student learning and reduce student test anxiety, and I know what two ways of doing this. One is frequent testing, the other is second chance testing. Other people call this retake testing in different contexts. So I'm going to show you some data about why I think this works. I don't think there's a lot of contention about that it works, but I have some data that helps give you insight into why I think it works. I'm going to talk really briefly about cheating. It would be nice to the thing that I'm arguing for, frequent testing and second chance testing, is basically running more tests. And it would be nice if we lived in a world where we could just put the tests out on the internet and have students do them, but sadly everybody in this room knows that we can no longer do this. So I'm going to share some data about cheating that we collected actually pre-pandemic, pre-Gen AI, but I think it's insightful. And in particular, if you haven't heard of the fraud triangle theory, this is not something that I came up with, but I think it's useful for thinking about what we can trust and why, and how students and people in general behave. I will end with what I think is the means for doing this, so securely and frequently testing students with low effort, which is our computer-based testing facility. I'm going to start with a definition. I'm not sure where all your backgrounds are, but in education, people distinguish two kinds of assessment. One is formative, which is during the learning process, the feedback you're giving to students to help them realize where they are and where they need to get to. The other is summative assessment, which is primarily for evaluating what's been learned at the end of a learning process. I'm going to focus this talk primarily on summative, not because it's more important, but because it's harder. And if you get the summative thing right, then the formative works. If you do not get the summative right, the formative does not matter. So that's my big claim, is that the summative is what we need to fix first. I'm going to give you a couple of what I'm going to call premises. These are statements that I believe to be true that help you understand where I'm coming from. I'm not going to provide any data for these, but just to give you an idea of the context that I'm coming from. So my first claim is that we need to assign grades, so we need to do summative assessment. I think that's not very arguable. Second thing that's important is assessments also help learning. So both motivationally, like the fact that a student has an exam or something, they will study to prepare for the exam, and that studying is where a lot of learning is happening. But also mechanically, I guess that's the point, is that what the education community believes learning happens is through what's called spaced retrieval practice. So retrieval practice is trying to apply the things that you've been taught, and spaced means we're doing some now, we're doing some later, we're doing some later. That doing it over time is important. And so by running tests, and in fact running more tests, we're giving them more opportunity for spaced retrieval practice. Third, Gen AI makes it hard to trust anything without knowing its provenance. I think it's a losing battle to look at an artifact that a student produces and decide, did they use AI to produce this or not? I don't want to play that game. Provenance is a word that means I can trace from when this thing was created to how it got to me. And my claim is proctored exams are interesting, and we can trust them because we can know the provenance. We can put a student in a situation where we know what they have access to. We can watch them generate the artifact. We can quickly curate the artifact, and because of that, we can trust that this was generated under those circumstances. I don't think exams are the solution to everything, but I think they do something really useful. And if we can do those well, then we can free up the humans to do some of the other stuff that would otherwise be cost prohibitive. Lastly, I'm going to show you some data from CS courses because that's what I happen to teach, and so it's easy for me to collect data, but I think the things I'm going to show you aren't CS specific. They're more about people. All right, so part one is my claim is that exam structure shapes student behavior. So my colleague in physics has a saying which is, students are a lot like people, and what we know about people is if you give them opportunities to procrastinate, they will often procrastinate. And so when you test students infrequently, you're encouraging them to procrastinate. That frequent testing, in contrast, encourages them to try to learn the material as it's being introduced, and you're going to get more studying in aggregate. So I'm going to show you data on that. And those, in turn, lead to higher exam performance. So, for example, a cumulative final exam, I think, is a relatively good proxy for what's been learned in a class. And so doing these things leads to higher final exam performance. In addition, frequent testing leads to lower anxiety. So one thing that I think is important is with Gen AI, we want to shift more of our grade to things that we know we can trust. We know proctored things or somehow interacting with your course staff. If you have 1 or 2 midterms in a final and you put 90% of their grade on those 3 events, they're going to be very anxious. And so by running many assessments, each one doesn't have to be so substantial that it freaks them out. All right, so there's a lot of research that had previously been done on frequent testing. I'm going to summarize some of it for you quickly. The first finding, which I think is true, is adding your first midterm exam has a substantial effect on their performance on the final exam. And then every subsequent midterm that you add beyond that, so when you're adding more and more midterm content, you're getting an effect, but it's diminishing returns. So as you add more midterm content, you're getting positive benefit on the final, but there's diminishing returns. The second finding is, given a constant amount of midterm material, if you cut it into more smaller pieces, they will do better on each of those pieces. So what's mixed is, does the cutting it into more smaller pieces have an effect on the final exam? So about half the studies find that more smaller pieces leads to a statistically significant improvement on final exam performance. The other half show no effect. So I have some explanation of why I think that happens, but so 2 things could be happening when you cut it into more smaller pieces. One is it becomes easier for them to learn somehow, and the other is that maybe it becomes easier for them to cram and forget. And so we need to be careful about how we design our exam structure so that we don't reward cramming and forgetting. So these things seem to be true, and there's a lot of data to support that. What there isn't a lot of data is the mechanisms of why they happen. And so that's what I'm going to try to show you is why I think these things are occurring. In addition, there's a lot of data that shows that students report lower anxiety and higher course ratings when you increase testing frequency. So a meta point of this talk is, even if you don't care about students, but you do care about your student evaluations, you should also be doing these things. So I'm going to show you some data now. This is from a CS1 for non-technical majors. This is what our College of Business requires. It's a relatively gentle introduction to programming, but it's run at a large scale, which is good for us because it means we collect a lot of data. I'm going to show you, yep.
Those findings, are they fairly invariant across scale of institution, length of term, year over year?
So a lot of this work was done in the sort of 60s to 80s period, and so a lot has changed since then, but I couldn't find a pattern on like STEM versus not STEM, but like there's a lot of variance in this data. So there's a meta-analysis that covers like 28 other publications and sees these things. The thing that I think is true about this, whether it has impact on the final exam, is is the course sort of cumulative by nature? So the class I'm going to show you, the CS1, a CS1 is one of the most cumulative classes just by structure, that every week you're teaching them stuff that relies on them knowing the stuff that you've taught up to this point. I'm going to show you that in this class, running frequent tests has a substantial impact on the final exam, and I think that's because it's cumulative. There's other courses, like my machine organization class, where we teach you a little of this and a little of this and a little of this, and everything's kind of related but kind of not related, that you can learn the things independently. I think if you're not careful in that context, if you do small exams, they will learn the thing and forget it, and if you don't have a cumulative final, they will have no incentive to retain it. So you either need to make the exams cumulative by structure, where like every midterm is 80% new material and 20% a review of what you've done up to this point, so that you encourage them to do the spaced retrieval practice that leads to retention. Are we good? Great question. All right. So what I'm going to show you is what's called a quasi-experimental study. It's hard to do randomized control classes in randomized control studies in actual classes. So this is a class that I'm teaching 2 semesters. It's me teaching. I changed very little between the 2 semesters except the testing regimen. Also, importantly, this is a terminal programming class for non-CS majors, and in part because of that, we get roughly the same student population in fall and spring. So there's not a big semester effect, whereas in our CS1 for majors, there's a huge semester effect because, you know, everybody's nodding, knows what I'm talking about. So we think it's roughly the same population in both semesters, and I'll show you some data on that. The main thing we changed was the testing regimen. So in both semesters, we run an exam 0. This is worth a very small percentage of their grade. And the purpose of this is this class is predominantly taken by freshmen who have never had an experience in our computer-based testing facility before. So the purpose of exam 0 is just to get them to go through the process and get comfortable with taking exams in our computer-based testing facility. In the infrequent semester, we had a 2-hour midterm that was worth 20% of their grade. We took this 2-hour midterm and we cracked it into 2 50-minute midterms that were worth 10% of their grade. So what we're going to call exam 1 and exam 2, these 2 together have the same amount of time and the same grade contribution as this midterm. Similarly, this 3-hour final, which was with 30% of their grade, was cracked into a 50-minute midterm worth 10% of their grade and a 2-hour final that was worth 20% of their grade. So I'm taking the same amount of assessment and I'm just cutting it into more smaller pieces. In a moment, I'm going to talk to you about second chance testing, but when I ran this experiment, we didn't have enough capacity for a class this size for me to run second chance exams, and so I did the next best approximation, which was the week before the exams, I gave them an unproctored quiz that they could do at home on their own. They were on an honor code. They had to click through something saying, I'm not going to cheat on this. The structure of this was very similar to the structure of this. In fact, there's about a 70% overlap between the question generators that we use to generate this and this. And the idea was that they would take this and hopefully, if they didn't do as well as they wanted, they would have a week to fix that before they took the thing that actually impacted their grade significantly. Yes?
Just a logistics question. Are these done in class or in the testing center? And if they're in the testing center, students can take them whenever, or are they all taking them at once?
So they're in the testing center, so they're not in class, and they're asynchronous, and I'll talk about this at the end, but we run them over a 3-day window, and because of that, we use a lot of randomization on the exams so that the students, you know, if you take it on Monday and I take it on Tuesday, you can tell me what was on your exam, but that doesn't help me very much. Is that answer the question? Other questions? Yeah.
It's the same, so since it's out of class, there's no impact on instructional time, and it is the same total amount of time students are spending in assessments across the term. But do you have any sense, maybe you'll get to this, do you have any sense of, is there an impact on, as a student, I have to schedule 4 things instead of 2 things, even though they add up to the same amount of time?
Yeah, so on our campus, we actually have to give back out-of-class testing time back to the students, so I will cancel some number of lectures. Like you said, It's the same amount of out-of-class time, so I'm canceling the same number of lectures in both of these cases. The students, if you ask the students, do you want more exams or fewer exams, they will say fewer exams. But if you say, do you want lots of little exams or a few big exams, they'll say, well, I want lots of little exams. So it depends on how you ask the question. The students love the asynchronous nature of these exams. They're able to schedule them around their busy and complicated lives. For the most part, students never complain to me about how many exams they have. Great questions. All right. So this semester had these quizzes. They were worth a small percentage of their grade. This is before Gen AI, which is important because now I would give, we don't do these anymore because unproctored things are meaningless. But before Gen AI, we could give them a small amount of credit, and many of them would actually do this thing seriously. In this semester, we didn't have the quizzes, but we gave these purely formative, so they're worth 0% of their grade, self-assessment. So every 2 weeks of the semester, they were getting feedback about how they were progressing in the class if they wanted it. But obviously, they had to elect into doing this. We weren't forcing them to do that, and I'll show you some data on how that affects things. Yep?
Just clarity, in the baseline, was that also asynchronous testing, or was that during the class time?
So the self-assess, this is in our computer-based testing facility. So this was asynchronous also. These are self-paced, so these are, they do it at home as many or few times as they want, whenever they want. Cool. All right. So sort of hinted at this already. The construction of our exams is they're generated by pools of question generators. So every slot on the exam has an associated pool of questions. And in fact, those questions are question generators. So there's a piece of code that uses randomization to make different versions of itself. So rather than writing individual questions, you write all the versions at once, and then you never write that question again. So because we have these large pools of question generators, we will typically run this class with the same exam semester after semester because I'm not worried about the students knowing what's on the exam because there's so many questions that they don't know which subset they're going to get that go ahead and try and memorize them all. That's called learning. If you can memorize all the things, you've effectively learned the topic. So that's really good for science because we can do apples to apples comparisons between these semesters because it's different students, but they're taking the same questions. All right, so at the top it says scores on E0 were statistically equivalent. So we looked at the E0 scores. In fact, the infrequent semester, what's called the baseline semester here, they did slightly better on E0, which makes it even more surprising that they did much worse on the actual assessments. But assume that they're roughly the same population. What we see is when we take this midterm and we crack it into two pieces, exam 1 and exam 2, they're doing better on each of the pieces than they are on the midterm. And similarly, for the final, it's cracked into the exam 3, and this is their 2-hour final. Again, they're doing better on the smaller pieces, and this translates into also better final exam performance. And so, again, a CS1 class is highly cumulative, and the main thing you're trying to do in a CS1 class is make sure that students don't fall off the train, because if they fall off the train, it's hard to get them back on the train. And so having the more frequent assessment, I think, is more helping the students stay on the train better. Yep?
Can you remind us if they were cumulative? Because the final is cumulative in the baseline.
The final is cumulative in both of them. So basically, this exam 3, if I go back to this picture, exam 3 is focusing on this material between exam 2 and exam 3. The final is focusing on this material between exam 3 and the final, plus it's also cumulative.
Exam 4 is cumulative.
So exam 4 is cumulative, and this final is cumulative, because this final is basically this plus this. All right. So on the cumulative part, they're doing better than they were in the infrequent stuff. So this is the 10,000-foot view. It's not very scientific. The scientific way of looking at this is you do a giant linear regression where for every student, you're trying to predict the score they got on a particular question by estimating how difficult that question is, plus, and this is the thing that we care about, how much better they're likely to do based on what context they see this question. And so that those betas are the things that we care about. And so we break this down by different kinds of questions, and I'll use the laser pointer because I point up there. So for questions that show up both on the midterm and exam 1, the students in the frequent testing semester are doing slightly better. And what's interesting is exam 1 is 2 or 3 weeks before the midterm. So these students have had substantially less practice on the material, but they're doing better, which seems surprising. By the time you get to the same point in the semester for the questions that are on both the midterm and exam 2, the frequently tested students are doing substantially better. Similarly for exam 3, again, 2 to 3 weeks before the end of the term, the questions that are on both the infrequent final and exam 3, they're either doing a little worse, a little better, or a lot better. But by the time we get to the same point in the semester, the frequently tested students are doing substantially better. So these 3 stars is a p-value of 0.001. So highly statistically significant results. So again, this is not surprising based on prior research. This is probably what we would expect. And so what I think is more interesting is sort of why this is happening, so we can think about what the students are doing differently in these 2 contexts. So we did surveys, we did interviews, we looked at other data sources. So I'm going to show you some of that data. So we did interviews, 12 students with 1 semester, 7 with the other semester. We did what's called qualitative research using grounded theory, which means we had multiple people look at the interviews independently, tagging them with what they thought was interesting, and then coming back together and reconciling those and identifying what are called themes. So when we see the same thing multiple times, we say, this is probably something meaningful that we should pay attention to. So I'm going to show you some of the themes along with one of the example quotes that was tagged that led us to believe that theme was interesting. So the first is infrequent testing leads to mass practice. So in an interview, a student said, if I only had like a midterm and a final, I'd probably start reviewing the week before and just start cramming for it. Yeah.
How big were each of these classes, and like how did you decide who to interview?
So they were on the order of 600 students per semester. I think it's long enough ago that I don't remember. So we may have, so we always have somebody who's not involved in running the course. We probably posted something in the class forum or at the end of lecture had a slide said, if you're interested, contact this person. For interviews, we typically will pay people for their time. Does that answer your question? So there wasn't any sort of stratified sampling or anything like that to make sure that we had a distribution, but we did sample until saturation, so we stopped seeing new stuff, at this point. So the student says, basically, if you only give me a few exams, I'm only going to study right before the exams. And what's interesting is because we have these large pools of question generators, one of the things that we do in our classes frequently is provide students a practice exam generator. So using the exam generator, we make a slightly different version, which gives them a button they can press, and every time they press it, they get a new practice exam. The exams are largely auto-graded, so they can do as few of the questions as they want. They get some immediate feedback. They can keep pressing the button until they're satisfied with how well they're doing. So we can look at the logs of their use of the practice exam generator, and what we see is about 95% of the practice is in the 48 hours leading up to when they take the exam. So almost independent of how big the exam is, the studying is happening in the 48 hours leading up to the exam. And so, we can take this one statement from a kid and we can sort of see in the class, yeah, this is kind of happening. The opposite of that is this one, which is frequent testing promotes more consistent studying. So this student said, I probably would have been forced into review and thus a bit more solid understanding in a week-by-week basis. What's interesting is we see this from faculty surveys from the other side. So we did a survey about faculty's use of the CBTF. One of the things we asked them about was frequent testing. This faculty member said, the CBTF allowed me to move from a 3 midterm model to a weekly quiz model. As a result, students are staying on top of the material better. Students are more participatory in class because they have not fallen behind. So it was obvious to this instructor when they changed their frequency of testing, the students were coming to class having understood the material. that just they were more interactive, more willing to answer questions in class. And lastly, this is my favorite. So this class is taught as a flipped class with active learning. I use clickers, so I show them pieces of code and I ask them about what the code does and things like that. In order to do that, I need them to read something before they come to class. My experience is if you tell students to read stuff, many of them won't. They just show up not having read stuff unless you have something that forces them to do the reading before they come to class. So I was using a textbook from Zilles that has a bunch of embedded activities that they have to do by a certain deadline in order to get points. So I'm trying to force them to read. And so this theme is frequent testing promotes conscientious practice. So I love this. The student said, had I had frequent exams, when I'm working through Zilles and stuff, I would make sure that I'm actually understanding what I'm doing instead of just trying to get the participation points. So what the student's saying is when you test me infrequently, I'm going to gather the points as I need to, but I'm going to try to procrastinate about actually learning the material. And my experience is sometimes when you procrastinate, it doesn't actually happen. Many of you have probably had the experience where you record lectures and put them up on the web, and students are like, oh, well, I don't have to come to class because I'll watch the video, but then they never watch the video. So what's cool about this is we can actually see this behavior class-wide. So we worked with Zilles, and so Zilles had independently come up with a statistic they called earnestness, which is like, how much does it look like you're actually trying to do this thing for real? So they have two kinds of activities in their textbook. One is multiple choice activities. And so in their textbook activities, there's no penalty for getting these wrong. So you can just blast through the options until you get to the right one, and then you get the points. And so a non-earnest student who is somebody who got something wrong and then within less than a second selected another option. So basically, there was no think time between getting it wrong and trying it again. And so what we see is between the infrequent and frequent testing semesters, the earnestness is statistically significantly higher in the frequent testing. So this is at a 0.001 p-value, so highly statistically significant, and an effect size of 0.24. That doesn't look like a lot, but like anybody who's done sort of classroom studies, like getting significant effect sizes is hard in the wild. The other kind they have is short answers. So these are fill in the blank things, and they have a help system that if you press the help button enough times, there's a show answer button that you can press that'll just tell you what to put in. So a non-earnest student is somebody who presses the show answer button. And so again, at a highly statistically level, you're seeing more earnestness when you're testing the students more frequently. So they're trying to learn the material as you're teaching it because there's no benefit to procrastinating because, I could procrastinate a couple days, but I might as well just learn it, now. So that's thing one. Yep.
Oh, sorry if this derails. You can.
No, go ahead.
You had this quote about the weekly quizzes. And here you're talking about this sort of flipped classroom, absorbing the material, then coming to lecture to practice. And the overall theme is often that more testing is better. So should we just, there's some trade-off here. You could replace every lecture with an exam.
Yeah, what's the sweet spot?
Something would presumably be lost. What's the, how do you know what the trade-off is? Is there a point where you get to, yeah.
How do I think about this? So my current thinking is that every 2 to 3 weeks is the sort of optimal rate that I think, you need more time for learning than you need for assessing the learning. Like it's faster, once they've learned the thing, it's pretty easy for them to demonstrate it. Most of the time is spent in the learning. The other thing I think about is this is not the only class that I'm teaching, that they're taking 4 other classes. And so if I'm testing if all those classes are testing every week, they have an exam every day of the week, which that seems too much to me. And so if I'm doing every 2 to 3 weeks and all the classes are doing every 2 to 3 weeks, maybe they have an exam and they're small exams, just 50 minutes long because, maybe every couple days. And so they're not in a constant state of stress. Yeah.
Related exactly to that, would your thinking change if it switches from semester to quarter, or is it really a time thing, 2 to 3 weeks?
I think 2 to 3 weeks. When I think it maybe comes down to how many courses they're taking. So, Colorado College has a block system where they take one class for 3.5 weeks. That would be fine to run exams every 2 days maybe, because it's the only class they're taking. So I think it's the total, when you take your class times how many classes they're taking, do you think that's reasonable? That's how I would think about it. Cool. So thing one is when you test more frequently, they try to learn the material as you're introducing it rather than gathering points and procrastinating the learning. The second thing is I think you get net more studying out of the students. So what I'm showing here on the y-axis is how many practice problems they did through that practice exam generator for the different assessments. So here is a 20% midterm, and they're doing about 220 practice problems on average to prepare for that midterm. That's more than this 10% midterm. Maybe this is 170, but it's less than this one plus this one. So remember, these two 10% exams equal that 20%, and so 170 plus 170 gives me 340 practice problems. So when I cut an exam into pieces, they study not half as much, but more than half as much for each of those pieces. Similarly, for this 30% final, we're getting around 320. That's more than the 20% final, but less than this 10% midterm plus the 20% final. The way I think about this is if they're going to do all of their studying in the 48 hours leading up to the thing, they have other stuff going on in those things. And so if you cut it into more exams, you're getting more of those 48-hour windows where they're actually doing the studying, and so they actually give you net more studying. This quiz was worth 2% of their grade, where this exam is 10% of the grade. So rationally, maybe you'd think they should study 1/5 as much, but they're studying like 2/5 as much. So again, it's sublinear all the way down. So the more things you do, the more studying you're getting. Again, in the Gen AI world where this is unproctored, they would study not at all. If you think otherwise, so a faculty I was talking to at one of the places I visited said, I think homework scores are inversely correlated with learning. The students that are getting 100 don't know anything, and it's the students that are not getting 100 that are actually learning stuff. So I truly think this is true. Okay, so these self-assessments, so everything I've showed you up to this point are the studying for the thing, but not the thing itself, that we give them these practice exams, so we give them practice quizzes, we give them practice exams. It's not including the thing itself. These self-assessments, because they were worth 0%, we let them do them as many times as they want, so it was sort of no point to give them a practice for the thing, we just let them do the thing. And what you see is when something is worth 0, at the beginning of the semester, maybe some of the students are earnest, but as the semester goes on and they get busier and busier, things that don't give them any credit, they don't spend any time on. And I don't blame the students. Their lives are busy and complicated. They have a lot of things pulling them in a lot of directions. They have to make choices. And so the choice is, if it's not going to help me get a grade in this class, most of them are not going to do it. Questions on those? So the two things, they're going to be more earnest as they're learning the material, and they're going to get net more studying when you have more frequent assessment. Yep.
How long on average in terms of number of questions are the actual exams? Like, is this roughly comparable to like doing one full-length practice exam or several full-length practice exams?
Several full-length practice exams. So these exams were on the order of 20 questions, and they go from everything. Here's a Boolean expression. Does this evaluate to true or false? All the way up to write a function that does, given a list in Python, creates a list that contains the subset of elements that have this property.
Several practice questions is like quite a lot.
Quite a lot. And so I think this is true, which is, so one of my mantras is you want to reduce the friction between a student's willingness to practice and their ability to practice. So if you give them a button that says, here's a bunch of practice problems that are directly relevant to what I'm trying to teach you in this class, they will press that button a lot. Some of them disturbingly so. But yeah.
Sorry, I didn't mean to.
No, go ahead.
But just on those lines, kind of building off that thread, do you have data that shows correlation between number of practice problems and improved performance on the actual exams? Or in other words, I I'm willing to accept that doing more practice problems is a good outcome in and of itself, but I'm curious if you can also, with a straight face, tell students, and this will help make you better.
No, and so I've spent a lot of time looking at student study behavior, and I haven't wrapped my head around it. The reason why number of practice problems doesn't correlate to final exam performance is, or the actual exam performance is, there are students who get it, they do one practice exam, they do well, and it translates into good performance. There's other students who aren't getting it, do one practice exam, still aren't getting it, and don't do well. So what seems to correlate more with final performance is the number of practice problems that you get correct, which is a hard thing to, that's not something that's under the control of the student directly. They just have to, the students that are struggling end up practicing more. Yeah.
Are the practice problems adaptive in any way, so the difficulty is?
No. I have thoughts. So I'll say it right now. My main collaborator, the guy who wrote PrairieLearn, and I have this argument of, should we be looking at what the students are getting wrong and funnel them into more practice problems on the things that are getting wrong, or should we do what we're doing, which is just give them practice exams and let them pick and choose which things they want to do? My claim is I want the students to be as efficient as possible in their practice. His claim is we want students to develop metacognition and realize what they know and what they don't know and learn to direct their practice. I think we're both right. Maybe we should lean towards me in freshman and sophomore level classes and more towards him in junior and senior level classes. But that's a thing that we talk about on a recurring basis. Yep.
Sort of along the line of the second to last question, I'm curious if you saw any correlation not with number of practice problems, but with perhaps percent or number of students who took any practice problems, or who took some marginal threshold of practice problems. Were you seeing a higher percentage of the class taking advantage of these practice problems, and was there a relationship between that percentage and final exam performance?
Yeah, so again, I don't think the number correlates. I haven't been able to find a clear correlation. We have seen that your performance on the last attempt of a particular kind of problem is predictive to how well you'll do on that kind of problem on an exam. So sometimes, we're creating these pools of problems, and sometimes we're using problems we've not run on exams before, and so it's hard to predict exactly how hard they are. We found that if we put the problems on homework or practice exams and then look at the final percentage, if for the class-wide, the average last attempt correctness on that is highly correlated to the exam score on that question on the actual exam. I don't know if that answers your question, but it's
not quite. My question was not about the questions that students are practicing with, but rather if a student, let's say you have some 30% of your students, pulling a number out of thin air, who maybe in the baseline doesn't do any practice questions at all, or only does practice questions on the midterm and not for the final. I'm curious if there's a relationship between if some percentage of those students now do any practice questions, how many students do practice when they wouldn't have previously?
Yeah, I don't think I have anything useful to say there. Maybe we can talk more after the talk. Yeah.
All right. One last question, if you don't mind.
You promise? Sorry.
On behalf of everyone.
Okay.
As much as I would love to think so, I don't teach in a silo. I teach as one of 4 or 5 classes the students are taking.
Yep.
My concern is that the results here could be demonstrably better for my class, but at the cost of my other colleagues who are teaching in a different style. Is there any reason to believe this is true or false?
I think it's the thing you do need to be concerned about. At some point you're squeezing blood from a rock, right? That students have a bunch of stuff. I think, so a thing I think about, students could study anytime they wanted to, but they're not. Many of us want to be more fit than we are, but we make choices that mean we don't go to the gym as often as we probably should. Some people choose to hire personal trainers to hold them accountable, to get them to do the thing that they want to do but have trouble making themselves do. This is what I think about when I think about frequent testing, is the student took my class with the intention of some grade target. They have challenges in the moment deciding, should I spend my time studying or should I spend my time doing something else? They want to do a certain wellness, in the class, and I'm helping them make the choice in the moment to study when they may otherwise watch Seinfeld. So there is a concern that I'm stealing from other classes, but I think I'm also mostly stealing from sort of low productivity activities. I also, again, the reason why I don't run weekly exams and I run exams every 2 to 3 weeks is because I don't want to overdo that. I don't know if that answers your question.
I know that, Chim, I promised this last one, but I want to follow up on that because it seems like I really like your analogy. There's this meta skill discipline of learning how to impose structure on your own life that I wonder if students aren't getting to the same degree in this setup. Do you have thoughts about potential downsides of that, or if maybe there's a curve where earlier in the student's undergraduate career they have more structure, and then by the time they're a senior they really should have only one midterm so that they are learning how to
so I think that's true, that I think this kind of scaffolding is most useful in the early years of the curriculum. We should give them more opportunities to develop skills. That said, this is not a student thing, this is a human thing. So NSF has data on when they got rid of proposal deadlines, they got fewer net proposals submitted because people were like, I could just do it next week, and they never do it. So,
they wish they still had that.
yeah. So at some level, yes, maybe, I think this is an interesting thing to think about, but I think right now we're at if you don't have, if you're doing one midterm and one final, you're probably too far on the wrong side of things. Cool. Okay, changing gears slightly. Second chance testing. So for us, this is offering retakes. We do it exactly one retake opportunity. So we do them 1 week apart. These are optional. You don't have to take the retake. Importantly, students have feedback on what they got right, what they got wrong, what their overall score is before they have to decide whether to do the retake. So for us, because they're taking the exams in the computer-based testing facility, we actually let them grade the exams interactively. So by the time they leave the CBTF, they know what questions they got right, which questions they got wrong, what their overall score is, to the extent that it's auto-graded. So anything that is not auto-graded, they won't know, but for most things, they will. For grading policy, we don't do full grade replacement. So theoretically, you think if they get 100% on the second exam, they should get 100% because they showed us they could do everything. In practice, what we find is if we do something like that, there's a group of students that'll say, well, I can get all the points on the second exam. I don't even have to take the first exam. And so we've basically just given them a week extension to learn the material, at which point they're falling behind because everything depends on everything else. So what we've settled on is something that puts weight on the first chance, and it can be a surprisingly small amount of weight. So an example of this policy is you get 90% of your maximum score and 10% of the minimum score. This seems to cause people to study seriously for the first exam and then take the second exam if they need to, but many of them don't because they've just studied for the first exam. I'm a huge fan of behavioral economics, which is all about the way people don't behave rationally. And so one of the things that's known is people tend to overvalue small things and undervalue large things. So like people buy lottery tickets thinking it's more likely to win the lottery than it actually is. And so I think it's basically no matter what this percentage is, whether it's 1% or 10% or 15%, it doesn't really matter exactly what it is, but there has to be some weight on it. Many people have the experience where you offer 1 point of extra credit for something, and you get this disproportionate response from the students, and that's that same effect. So when we do second chance testing, a couple things happening. One is it reduces failure rates and tightens the distribution. Another is the students report having lower anxiety. And the third is they perceive it as more fair. That it's rare that a student says, you gave me 2 opportunities to do this exam. I failed because of something you did and not something that I did. All right, so the point of retakes is to approximate what's called mastery learning. This is not mastery learning. This is what I would call one-shot learning, which is what a lot of people do, which is our class is running along. At some point, I give you an assessment. If you are doing well, you do well on it. If not, you don't. But sorry, the class is moving on. Sometimes these small failures cascade into larger and larger failures as the semester progresses. There's a lot of belief in the education community that the right thing to do is what's called mastery learning, which is, hey, if you're struggling with something, you should keep working on it until you master it and then only move on to the next topic, and you should keep doing that. The problem is this doesn't fit very well in our fixed length semesters, and so very few people do this truly. And so what I think of second chance testing is basically trying to approximate that in fixed length semesters, which is, hey, if you're struggling, the class is going to move on, but I'm going to give you an opportunity and an incentive to remediate what you struggled with so that hopefully you can demonstrate to me that you mastered it. And in that way, maybe I'm not, going to get you up here, but I'm going to prevent that worst case of you just cascading failures and crashing out. So hopefully you do at least well enough that you pass the class and progress to the next one. Importantly, these students are working harder than these students. So going back to all the questions of how many exams you're doing, this student is doing more work because they have to learn the new stuff in parallel with relearning the old stuff. And so I would encourage advising students in this situation to maybe take fewer classes, that we can't modulate the length of the semester, but we can modulate how many classes you're taking based on sort of how quickly you're learning things. All right. So to me, the largest value of second chance testing or retake testing is it lets me maintain high standards. I don't know if you've had the experience where you run an exam and your students do really poorly and you have two choices, which is either fail a bunch of people or you curve it so you're like, oh, it's fine that you failed this exam, I'll still give you a good grade. Second chance testing lets you say to the students, hey, a bunch of you struggled with this. I know you can do this. You have a week. Figure it out. Come back and show me that you can do this. So this is some data from the hardest learning objective in my machine organization class. So we have a 50-minute exam where we give them working Verilog for a single cycle MIP subset processor. I say, here's a new instruction you've never seen before. Modify the Verilog so that it now supports this new instruction without breaking any of the other instructions. My belief is if they can do that, then they understand how a computer works, at least at some level of the fetch, decode, execute, control signals and stuff like that. When we run that, typically a bunch of students in this particular semester, 30% of the students failed to demonstrate this learning objective on the first attempt, but by the second attempt, that number dropped to about 3%. So I could say to the students, no, you really need to learn how to do this. They went away, figured it out, came back. That in fact, I see more metacognition from students in between the first and second exams than you see anywhere else. You can get up at the beginning of the semester and say, here's how you should study for my class. And they're like, yeah, blah, 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 we'll do what we're gonna do. They're gonna do what they do. If that doesn't work, they'll fail, and then they'll be ready to listen to you and be like, oh, how do I actually study for this class? So especially the combination of frequent testing and second chance testing means when they fail, it's happening early in the semester, so they're not so far behind that they can't come back. When you do this over the whole semester, what you see is distributions like this. So what I'm showing you is two distributions, a yellow one and a blue one. This purple-brown is the overlap of the two distributions. What you get is, this yellow one is what were the exam averages if we only looked at their first chance scores, and the blue one is if we look at both their first and second chance scores. And so what you see is a tightening of the distribution, and in particular, we're pulling in this tail. So we have a whole bunch of students that were struggling and are now passing. It doesn't save everybody, so there's some students down here that, it's not a panacea. Sometimes, if your grandmother dies and you get mono and your dog divorces you all in the same semester, you just need to come back next semester. There's, I think assuming 100%, pass rate, it may not be reasonable. We did a bunch of interviews and surveys about this. Students almost invariably like this. I view retake tests positively. I wish more of my courses would offer retake tests. This is a 6-item Likert scale, so it's questions on a scale of 1 to 5 about test anxiety. So these are things like, I have trouble concentrating during exams because I'm worrying about how I'm going to perform, or my hands get sweaty during exams. We asked it twice, once for exams in general, that's this distribution, and once for exams that offer second chances. And so visually, you can just see there's a huge movement to the left. If you do math on this, which is a little dodgy, you get about a 30% reduction in self-reported test anxiety when students have a second chance opportunity. And we have students from interviews that say things like, I never took the second chance, but I was less anxious knowing that it was there if I needed it. So I love that because it's free. I didn't spend any resources on that exam, but the student feels better about it. Retake tests allowed me to better demonstrate my true test-taking ability. I feel that faculty that offer retake tests care more about their students than faculty that don't offer retake tests. So again, even if you don't care about your students, but you want to get good student evaluations. All right, so closing the loop of putting these two things together, this is from one of our mechanical engineering classes, Intro to Solid Mechanics. They went from a semester where they ran 2 paper midterms. These were 2-hour-long evening exams. And they went from that to 5 50-minute quizzes along with 5 second chances. So these quizzes were 50 minutes long, so 2 hours versus 5 times 50 is about the same amount of testing time plus the second chances. These paper midterms, students were expected to show their work and they were given partial credit based on that. The computer-based midterms were only checking the final answer. And that's important because the experiment was, we're comparing final exam grades. Because we don't hand back finals, basically what they did between these 2 semesters is they ran the same final both semesters. And it was a paper-based 3-hour-long final where the students had to show their work. So the students that took the computer-based quizzes were at a mode disadvantage. They hadn't practiced in this, handwritten mode. But what you see is the number of D's and F's on this final drops significantly. And there's just a big shift of motion towards A's. So the more frequent, along with the incentive to go back and remediate the things that you didn't understand, translated into better final exam performance, and in a cumulative final is a reasonable proxy for sort of how much has been learned in the class. So we have a lot of evidence that suggests that this is a good thing. All right. A common thread of this is we run more exams, good things happen, but like how as faculty can we run more exams? It sounds like a lot of work. It would be great if we could run unproctored online exams, but there's this thing called cheating. We saw this class before, unproctored quiz, proctored exam. We realized this was a cheating honeypot. We basically put this thing out there and we could see, what happens. Well, what happens is people cheat. So they do better on the unproctored thing, even though it's a week earlier. They have had 1 less week of practice, but they're doing better. What's even more interesting is the amount they're doing better increases as the semester progresses. So the first one, they start out about the same. By the end of the semester, more and more people are outperforming on the unproctored thing than the proctored thing. It's not because they're studying more. The amount of studying they're doing for the unproctored thing is going down while their relative performance is going up. So most of this makes sense. So fraud triangle theory is all about why do people commit frauds, whether it's Wall Street or cheating or whatnot. The thing that's really interesting to me that I hadn't thought about was the rationalization. In general, people want to think about themselves as good people. Students know cheating is wrong. There's surveys and interviews that they know it's wrong. So how do I, as a good person, do this thing that I know is wrong? I come up with a rationalization. I say things like, this class is too hard for anybody to do well in without cheating. The professor doesn't care if we cheat. Everybody's cheating. And what's interesting is all 3 of these things, the perceived pressure, perceived opportunity, and rationalization, increase as the semester goes on. And yeah, so it's a useful thing to think about when you're thinking about cheating. All right. So we want to run frequent exams. We can't do it online. What's the solution? So to us, the enabling technology is our computer-based testing facility. So it reduces the effort of running an assessment without burdening, it reduces the effort of running assessments. So you can do more of them without losing your mind. It's basically a computer lab that we proctor, and now it's a proctored computer lab. Importantly, we control the machine, so we can control the internet on the machine, so we know they're not using Gen AI, and the students don't freak out because we're not doing anything weird to their computer, we're doing something to our computer. They seem to be happy coming in and using our computers no matter what state they're in. We check in their IDs, we assign them to random machines, we run the exams on computers, and so we run 12 hours a day, 7 days a week. So these are the most utilized spaces on campus. We run at about 70% capacity on average throughout the whole semester. Many exams running simultaneously in the room at the same time.
Real quick, do you only need one proctor per
We use
session?
2 proctors per room, but that's independent of the size of the room. So we have some rooms that are 45 seats, and we have other rooms that are 90 seats. We put 2 proctors in them because if one has to go to the bathroom or one's interacting with a student, you still want somebody sort of paying attention to the room. So it's cheaper to run bigger rooms up to a point. There's 4 things that I think make this work. The first is you need a way to ask sophisticated questions. We didn't want to dumb down our exams because we were running them on computers. So my colleague built a thing called PrairieLearn, which is the most flexible question asking platform in the universe. Anything you can do in a web browser, anything you could do. Many of you use Gradescope. Gradescope's autograder architecture is derived from PrairieLearn's. So if you like that, you also like PrairieLearn. Basically, my exams have actually gotten more sophisticated now than they ever were on paper. Again, I have students write and debug Verilog as part of one of their exams. The second thing is writing question generators. So instead of writing individual questions, you think of all the ways you could ask this question. You write it once, you never write it again. It's great for students and homework because they can keep practicing as much as they want. It's also great because we run our exams asynchronously, and it lets us very easily give students different exams that are roughly the same difficulty. This is the one that some people get stuck on, which is asynchronous exams. It is a big pain to try to get everybody in the same place to take an exam at the same time. And so our claim is that you shouldn't try. It is so good. I cannot explain how good this is. So we typically do a 3-day window. Basically, it means you don't have to worry about conflict exams at all anymore. Students just find a time that works for them. You need to deal with the fact that it's asynchronous, so you need randomization on your exam. But once you swallow that, student gets mono. I take that 3-day window. I turn it into 11-day window. It's 1 email round trip. You know, I almost forget when my exams are running because I don't have to know. It also lets you run very large classes, even in a small computer lab. Lastly is centralizing and professionalizing the proctors. It's really inefficient and expensive to have faculty and their TAs proctor. You're having skilled labor doing a relatively unskilled task. Instead, you should farm that out to people that train, that are doing this every day. They will actually do a better job than your TAs that you hardly train to do this thing. So you outsource it. That means you don't need to worry about who's proctoring what. You're not doing the administrative overhead. Somebody else is doing this. So again, we run 12 hours a day, 7 days a week. With automated exam scheduling, so the students self-schedule, we do a lot of auto-grading, and outsourcing the proctoring, it means my exams are almost free to me. So my machine organization class, I solo teach at 300 students. I run 7 midterms with 7 second chance exams and a comprehensive final. And it's so good. Yes?
How do you handle student questions during the exam when you don't have a subject matter expert in the room?
My claim is if a student has to ask a question about your exam, you have a bug in your exam. So also, I think it's an equity problem that some students know they can ask questions and other students don't. So we've thought about it a lot. We think it's the right answer. One nice thing is when you run your exams asynchronously, the strongest students will take it whenever is convenient. The weakest students will put it off as far as possible. And so what you do is if you're putting a bunch of new questions on it, you just watch your exam the first couple hours it runs. in PrairieLearn, there's a button that says report a bug in this question. Your best students can articulately explain what's wrong with the questions. You watch it, you fix it, and 97% of your students don't see the problem. This is so much better than when you're running a synchronous exam and the TAs realize there's a bug and they're calling between the rooms and figuring out, oh, what a nightmare. And then for that student, you just give them full credit on the question because they would have gotten full credit anyway. We will change it during the exam. But I mostly don't do that anymore because I'm running the same questions. And the students have seen some of these questions before on homework and practice exams. So they've already been debugged, and the students are already very comfortable with the formats.
I can stay for another hour, but...
Yes, so we can stop there. So...
Thanks, everyone, for all the great questions, and for people out in the internet, thanks for watching. And Greg, this was great.
Cool. And if anybody wants to stick around and ask more questions, I'm happy to answer them.